7 of you who would like to present their code today, which is really cool. So today's plan, as far as today's plan goes, let's do it this way. I want to make sure that everybody is comfortable coding. Okay, we have to get there. Now, as you start your adventure, in coding, it's my video is not started. Okay, there you go. Oh, I need to switch the light on. That's better. All right. Okay, so I think you'll have to find your own groove, and it's different for different people. But at the very least, I would expect that you would spend at least 1 hour, okay, at least 1 hour coding every single day. Now, if you don't code an hour each day, just keep this in mind. It's okay. You're free not to code for a particular day, but you have to be aware of the cost of not coding on a particular day, because coding is really practice, right? You're just like when you're dancing or learning to dance or gymnastics. I don't know. I haven't done gym, right? So you have to perform these physical exercises to strengthen your muscles and your resolve. Yes. So likewise, programming. So you have to keep at it. If you don't keep at it, the next day you come back to it. You just have to be mentally prepared to say, well, I skipped 2 days. And so the amount of work I have to put in today is not just 1 hour, which is the usual thing to do. It's not even 3 hours to make up for the 2 days that I missed, but it is actually, some other exponential function of the time lost, right? So the days that you miss don't just add up. They actually expand and add up, because what happens is that you just lose your memory of what you've done. And you've not nailed it in, right? It's just floating above you. And maybe you've held on to it, but you have to nail it in. And the only way to nail it in is to keep practicing. And the only way to keep practicing really is to love it, because I have not seen a single person do anything in their lives and get really, really good at it until they got to the stage where they started loving it, right? Because if you don't love it, you're doing it for someone else. But if you love it, you're doing it for yourself. And nobody ever succeeds in anything they're doing for someone else, right? So if you're following someone else's dream, yeah, well, okay, well, maybe you'll achieve something, but you've achieved someone else's end. It's not your own end. Okay, so the best way to succeed here is just to fall in love with it. And it's not like, programming or mathematics. They're not hard things to fall in love with, because they already have these patterns, right? What do people fall in love with? They fall in love with symmetry, pattern, beauty, right? That kind of thing. And, art in general, but mathematics and computer science is full of this thing. So you can actually identify these things and start enjoying it. In the beginning, maybe it's a little bit of a tedium to do it, but you'll find that the more you do it, the more you enjoy it. And pretty soon, you're going to say to your hot date, yeah, too bad. I don't want to go out today. I don't want to, come and see you today, because I got this really cool program I need to cut. Okay. So when you get to that stage, you're making these trade-offs, and you can pick and choose what you want to do at any particular time. That's where you want to be. And I think that's a recipe. That's a recipe for grand success. Okay. Not just mediocre success, but grand success, because that gives you a whole other level of high. All right. So today, what I'd like to do is by the end of today, let's try and do loops and branching statements. We have a bunch of students. We're going to go through them one after another. What we'll do is I don't want to go, not an alphabetical order or not any particular order, but I'll write a small program here on screen, get all the names, even the people who didn't send me email. If you're interested, send me an email. We'll put them in a list. I'll shuffle the list and print it out, and then we'll have an algorithmically selected sequence of students, okay, who are going to come up to the screen, grab the screen, and give a demo. How about that? Is that okay? Does that work for you guys?
Okay. By the way, I did send you an email like 20 minutes ago with.
I saw your email, Daniel. Yeah, so you'll be in the list too. So today, as when we make that list, we'll just put in the names of everybody who's interested, right? Not. And Daniel, your game would be really cool to play too. So that would be nice. So Daniel's written a nice little game that we can take a look at. However, you got to wait. You can't say, hey, I want to see Daniel's game. Let him go first so that I can see that and take off from this class. No, okay. So we're going to let the algorithm decide And then whenever Daniel comes up, and if it places him at the very end and we never get to him this class, that's too bad, okay? So, but we're gonna try. We're gonna try to get through everybody, and everybody gets a chance. Okay, now also the other thing is, if you have not coded your first program, doesn't matter, it can just be a hello world, okay? You have to get the first program going by the end of today. Every single person who's in class, pass this message on to all the other people who are late or have missed class today, right? And some of the online students, lectures are optional, right? So some of them, some of you don't turn up to these lectures, especially since the morning and coming up to daylight savings going off and all, right? So pass the message on to them, right? If they don't cut their first program by the end of this week, the chances are very, very high, right, that those students will drop the class by week 4 or week 5, withdraw, drop, and things like that. Or even if they stick around, they'll probably not get a grade better than B, right? If that's your goal, yeah, okay. But if that's your goal, you're probably not even doing programming for yourself. You're doing programming because someone forced you to do it, right? Or maybe you're doing programming because all these companies out there and you want to make a 6-figure salary. So, but in order to really get into it by this week, okay, promise me and promise yourself. Yeah, I don't believe in promises, honestly, but only promises made to yourself, right? Because if you fail to deliver, then you're held accountable only by yourself, right? I'm not going to police this. I can't police this, right? Because for all I know, you could get mom or dad to write your program for you. So promise yourself that by the end of this week, you would have your first program up and running, right? And by the way, even if it means you're going to copy one of today's programs from one of your classmates, that's fine. Go ahead, copy the program, get it run. After it's running, go into that program and then edit it. Delete some cout statements, add more values. +5, +7. Make that program your own by changing it, okay? And then run it. So when you do that, let me say, all right, take a random program, let's say Daniel's program or Giorgio's program or something, and you're going to make changes to it. Let's say you are going to, in your own time later today, you're going to make 10, okay? Get a notebook, make these, what do you call these things? And then, vertical lines, and then there's a name for it, right? Histogram, what do you call this ancient counting technique? You make these vertical lines and you cross off, vertical lines and cross off. There was a name for it, right? What are these marks? Does nobody ever counts like that anymore?
I forgot the name, but I think it was like 5 marks. It was 4 marks, and then the 5th one was diagonal.
Are they tally marks?
Tally marks. Okay, thank you, whoever that was. Okay, yeah. So make these tally marks. You need to make 2 of those. Okay, and each one of those marks is a change you have made. You know in your mind what kind of change it is, not like moving a semicolon by 1 space and things like that, okay? It needs to be a change that causes a change in the behavior of the program, not the way that it looks, okay? So 10 changes. 10 changes of your own choice, taking a program written by someone else, Andy or Giorgio or Daniel or whoever it is, right? Take that program, 10 changes of your own. You don't have to share it with anyone. In the privacy of your home, okay? Make these changes, and each time you make a change, run it, see the output, and see, hey, that's really cool. Okay, now let me try something else. Okay, maybe even try drawing an ASCII picture, right? So these things you should try and have fun. Okay, we're getting to a stage where we can start having fun, and not just information download. When you start having fun, it'll be fun. Okay, all right. If everybody, so before we get into coding and generate the list of students, let me make sure that you guys are all on the same page as far as the logistics goes. Are you all happy with the way things are progressing, the pace at which you're picking up material, the way the classes are delivered? Are you all feeling comfortable enough? Yeah? Okay, that's great. All right, and thank you so much for Andy and Andrew, for example, right? So and some other people too, who take the trouble to reel me back in, okay? Because at the end of the day, we also have to cover all the material we have to cover, right? So, and then it's important for you guys to, hey, come back on, talk about this. And Daniel also did that a couple of times yesterday, on Tuesday. So thank you guys. Okay. All right. So if you have no other questions, what we'll do now is move on to generating that list of students. It'll also be a small program, and I'll talk you through that program as I type it out. And then
I have a question.
Yeah.
So I did my code yesterday for today's for today's assignment, if you want to
Yes.
call it. But I didn't send you an email. Should I send you an email?
No, no, that's fine. But so that's what I said. So when I make this list of students who want to demo today, everybody who, whether you sent me an email before or not, just send me, you speak out your first name so I can type it in. Okay, so you'll see what I mean.
Okay.
Okay, so I'm
I'll,
going to stop sharing. Yeah, yeah, go ahead.
I also posted it on the Reddit.
Yeah,
The
yeah,
Reddit.
I saw that. I saw that, Giorgio. Yeah, this is cool. I saw a bunch of really cool programs that some people have sent me. You don't have to send me the program, by the way. Okay, I trust you to just slap your program on the screen when we start working, and and take it from there. You don't have to send it to me and get my okay and so on and so forth. You know,
Okay.
I do enjoy looking at your code, but I can enjoy it just as well looking at it with the rest of you, right? All of us together at the same time, and I think that's fine with me. Okay, so what I'm going to do now is I'm going to share my screen so that I can open a browser window. Actually, I don't need to do a browser window. I'll just do it on on the terminal here. Okay. Are we recording this meeting? I want to make sure we're recording this meeting.
We are. I heard the voice earlier.
Okay. All right, great. So let me go to, this temp directory. I'm going to create a small program here, which is essentially going to get a list of student names and then, shuffle those student names and print them out again, okay? You don't need to know the nitty-gritty details of everything in here because I'm going to be using arrays and vector, a vector class. And actually, I'll just use a vector class, okay? A vector class, which you get to know, I don't know, maybe what is the first quest that requires you to use a vector? 5. Yeah, it's actually 6. Okay, it's quest number 6, and the crow quest, I think. So don't worry about the vector class. I'll talk you through it a little bit. Okay, so I'm going to say edit the file called select students.cpp, right? Okay, hash include stdio dot, iostream, and hash include, I'm going to accept user input. No, I'm not going to accept user input. I'm just going to process stuff and print it out on screen, so I don't need iString stream and so on. I'll just say vector, okay, include. I'm going to be using a vector, which is basically an array. We'll get to know this very soon, okay? So don't worry about it. Don't worry about this, what I'm doing right now, okay? Using namespace standard, okay, and main, okay? And let me say vector of string students equals, okay, now I'm going to stick in some names that I remember, and the rest of you can either correct me or tell me your names to put in here, okay? So I know Daniel sent me a name. Yeah, right, Daniel sent me a request to demo today. Giorgio. Andy, did you send me something?
Yeah, I did, but I'm okay not presenting.
Okay, well, I don't know, maybe you're at the end. Okay, Andrew, did you also send me something?
I did.
Okay, who else? I've only got 4. Okay, so tell me more. I think we can easily have up to 10 people, sharing their code today, easily. Okay, so give me more names. Okay, so take your time, maybe 2 minutes. If you're brave enough to
A couple
share.
of you are commenting in the text.
No. Speak it out, guys. Hit the space bar. Hit the space bar and tell me your first name.
Steven.
Steven, okay, yeah.
Sumit.
Sumaid.
Yeah.
S-U-M-E-E-T. Sumit, okay. Who else? Who else wants to go? Right, doesn't matter. You can also start. Momo, do you want to go?
Yeah, I think I sent. Sorry, I forgot
Yeah,
to.
then you should have said Momo.
Yeah.
Yeah, I got you. Who else? Yeah, it's it doesn't matter if your program doesn't work. That's the important thing. Keep in mind, doesn't matter. We'll all fix it up, okay? We'll all fix up your program and then run it. And by the way, it's better if your program doesn't work, because here is a great chance. In this course, you're not allowed to share your code with anyone, okay? So if your program doesn't work, your Quest program doesn't work, or something like that, you can share it with someone else, a friend, or parents and say, hey, what's going on here? You cannot do that. But this is a unique opportunity. If you have code that doesn't work, it shouldn't be Quest code, okay? Not Quest code. You have code that doesn't work. Here is a great chance to just put it up on the screen and say, hey, this doesn't work. Let's all fix it together. And in the process of fixing it together, you'll know why it doesn't work. So you can fix it, okay? And so go ahead, even if your program doesn't work. Yeah, these are very simple programs, right? Eventually, you'll get to a place where you're able to write these programs in your dreams, right? In your sleep. It's nothing at all. I mean, these programs become like alphabetic letters in English, right? So when I say Daniel, I'm not thinking about D-A-N. Yeah, I'm just saying Daniel, and so these kinds of programs, even though they're like 20 lines and bigger programs, they will eventually, when you get to know them, shrink down to the size of a letter, okay? And they just become little building blocks that you can deploy, right? And then in your mind, you have a lot of these little building blocks, and then you come up with a massive program, right? A big program that you want to choreograph, right? So you want to take this and turn that into this, right? And you can't do that in a single step. You can't do that in a single step, right? So you need to take multiple steps in particular ways, okay? And navigate that space and slowly get to the end. But how do you do that? If you didn't know programming, you wouldn't do that, right? But because you've learned all these little things and tucked away these little jewels in your mind, all right? So to go from here to here, I'm going to use that move, okay? To go from here to there, I'm going to use that move, right? And each time you're not picking a single move, right? Even to go from here to here, you may have like, oh, did you see, wow, the squirrel must have come and gone. I don't know. Wow, I left a cookie out for that and it's gone now. But it should have been caught in my iPad. Oh, damn. I don't know. If you were looking at my iPad window, maybe you saw it. Okay, cool. I was hoping to capture it. Not capture the squirrel, but the footage of the squirrel. It comes at 7:45 usually, but today. All right. So, yeah. So you want to, even for doing the same thing, once upon a time, there was a language called Perl, okay? Perl, P-E-R-L. And Perl, I think it stood for pattern extraction and resource language or something like that, okay? And Perl, and one of the mottos, not mottos, one of the famous sayings about Perl, I think, was that there's many ways to do it, or more than one way to do it, or something like that. So anytime someone shared a piece of code in a Perl forum, immediately there'll be pearls of poems, okay, by all of these online, this is back in the 90s, right? Back in the 90s when Perl was still popular and I was still using Perl for a lot of things. And in the forums, people would, one person posts something in Perl and immediately people will say, hey, you can do it this way, this way, this way. 10 or 20 different ways of doing the same thing, all in Perl, okay? And some of them are really, really cryptic. You can't even understand what the hell is going on, but you get the results. And some of them, pretty straightforward. But they're all very, beautiful, because I think, Perl itself, I think, is an ugly language today. But, people who created these little vignettes, as it were, and they took time and the pains to make sure that even though their program was very cryptic, it at least looked pretty and things like that. So yeah. So there's many ways to do a particular thing, right? Like in any art form, there's many ways, and it's important that you know multiple ways of doing the same thing. You have to, right? Because if you don't know multiple ways, there's only one path you can follow. There's only one dance you can dance, right? But if you know many ways, then the number of dances you can do is now exponentially greater, right? Not just linearly, it's exponentially, because at each path you can take 5 or n, and then at each path you can do, let's say, n branches on average, and you have 10 steps, then you have n to the 10, because at each path you have 10 options, right? And so you have now n to the 10 different dances you can perform, all and not consciously even, right? Because at each point you're not thinking ahead, I'm going to perform that particular move sequence 10 steps from now. No, at each step you're just looking at what's the best thing to do right now, what is the most aesthetically pleasing or most efficient way of going to the next step. That's all you're thinking of, because already from here to here I need these steps. At a high level you pick them up, and then when you're actually going to perform these steps, you know the high level direction you want to go. Now you can do a fine level tuning and say, okay, well, I want to go in that direction, but there's 3 different paths. Which one would be most beautiful, Okay, and then you run that through in your mind. You run that before even doing that. You run that in your mind. You simulate that in your mind, because it's single steps you can simulate, right? You can't simulate the whole program in your head. Impossible. Yes, because but you can simulate these single steps in your mind. That's how debugging happens, right? Debugging is you step through your code one step at a time. So many times when you have like 20 lines or 30 lines and it doesn't do what you want to do, how do you debug it, right? Because it's hard to run the entire logic in your head. However, if you break it down and say, I'm going to run one step at a time, then you can say, all right, these single steps you can simulate in your head and say, okay, well, if I do this, it's going to happen like that. All right. So, and this can happen really fast. This can happen really fast. You know, as some of you who are dancers or singers know, right? The next thing to do has already been played in your head. Okay. Before the audience sees it, it's already been played in your head. And then not only that, your brain is working so fast that not only that particular thing has been played, it's like 10 or 20 different ways of doing the same thing has been played in your head. And then in your mind, right, in your mindscape, you're looking at what has happened after each one of those options, each one of those simulations, right? Each one of those options has been played out. You can look, all right, you know, if I do it, that happens in 10 milliseconds. If I do this, it happens in 15 milliseconds, 11 milliseconds. And that looks prettier. This looks, so, yeah, and then you make that choice and say, okay, this is what I'm going to do. Now, that is what distinguishes one programmer from another, one singer from another, right? Because, you know, it's micro choices they make. Because end to end, it's always the same. Most, right? End to end is the same, but what distinguishes one product from another is the micro choices, right? And you will only get to be a solid, fantastic developer or a product engineer if you know all these micro choices, right? So you know as many of these micro choices as possible. Then you can subconsciously select the best one at each stage, or the one that aligns with your aesthetic judgment, or judgment of efficiency and things like that. You pick that. And then you can chart your course. Okay, so who else? Tell me some more names. Let me go, two more people, and then we'll.
Adam.
Adam, thank you, Adam. And who else? One more, please. Okay, all right, we'll do these. Okay, so but guys,
you can add my name too. This is Sumedh.
I added your name already.
Oh, this is SUMEDH.
Oh. Yes. I know. Yes. Okay. Sumedh. Okay, great. And those are the people that I have in my list right now who will be demoing their code. So what I'm going to do now is take this list and shuffle it. Okay. And I think the command.
Sorry, Professor. I also sent you an email on yesterday.
Oh, Ming, right?
Yes.
Just say Ming or Ming Fai?
Ming Fai or Ming is both okay.
Okay, I'll just say Ming, okay?
Okay.
All right. All right, now there is a command that's built in for this class. I think it's vector shuffle. So let me try that. Students dot. Well, if some of you have time, just look it up online to see if the syntax is right. I haven't used this for a very long time, this particular method of the vector class, but you can look it up and tell me if that's right. Now all I need to do is for size t, I equals 0, I is less than students dot size I plus plus, okay, and then I'm going to say cout less than SN, and let me also say the order, okay, I. Okay. All right, so that's the program I'm going to run. And when I run this program, it is going to take that list of students that we have up here. Can you all see the screen?
Yes.
Yeah, my chat window disappeared. Hang on. Why is it? Oh, the chat window is in a different. Where's my chat window?
If you want to go to the chat, you go to like the top bar and to the 3 dots that say more, and it should come on the drop down menu.
Oh, I say that the trouble with this for me is that it's in a different desktop. I just need to find out which one it is. Okay, show chat. Okay. Oh, Shift Command H. Shift Command H. I have to remember that. Shift Command H. Yeah. Okay, so I got, Muhammad, you also want a demo? Do you also want a demo? Who else? Nee and Muhammad. I don't know. Well, if you want a demo, just pipe up here, okay? And tell me your name. But otherwise, I'll have to move the chat window to the other thing. Why is, yeah, this is a little bit of a pain. Let me see if I can move the video bar to the bottom. Okay, in the chat here, and then my terminal. Wow. So if I move to the terminal desktop, the chat window is on the other desktop, and can't seem to drag it over. I can move this terminal to the other desktop. Hang on. Yeah, that's much better. Now I can see the chat as well as work on the terminal. All right, so is everybody clear on what this program does? There is a class called Vector, okay? It's a special kind of class. It's called a template class, and we won't go into it now, but essentially it gives you the same functionality of that an array gives you, which we'll talk about later. It stores a list of strings, or strings, in this case strings, because I said I want a vector of strings, and then there is a method that's defined on it. It's a function, right? So it'll go and shuffle the strings, and then I'm going to iterate through the vector and print all the names, okay? So let's see. Now let me go ahead and make select students, okay? Hang on. Oh, student string. I can't, do I need to do this? I've never done STD before. Let me see. Oh, I just have a syntax error maybe.
It looks like you're using C++.
Oh.
That type of construction was not introduced until later, I think.
Yeah, I thought I was, well, let's just do it step by step, okay? Let me do this way. Okay, we'll just do a macro here.
Also, why are you using a vector? An arrays are fixed width and more memory efficient, and you're not mutating it.
Yeah, so why would I use that? Why don't you tell me?
Because whenever you know that there's never.
No, why would I use a vector here is what I'm asking.
I mean, I don't know, unless you are trying.
Yeah, take a guess. It's okay. You take a guess.
I mean, I guess that you're expecting to
utilize shuffle.
Yeah, thank you.
Array doesn't have a shuffle method. I forgot.
Okay, something. Oh, I'm missing a code. What happened? Oh, my macro. Okay. Oh, okay. All right. So let me do the macro properly. Okay. So I need to go here, push back. Okay. And then to the end. Okay. Oh, I forgot the student. Okay. Okay. Let me try to see if this works. Did it work? Oh, something. I'm just messing up the macro on Emacs, but let me just do the normal thing here. I'm just going to copy. Okay.
You have double quotations on the bottom four.
Yeah, I got it. Thank you. Oh, on all of them. Okay.
And the one for Andy is currently missing a parenthesis.
Oh yeah, and they're all missing the
semicolon.
Yeah, it probably would have been faster to just type it all in instead of doing this silly macro here. Okay.
Yeah, the double quotes. Yep, there you go. You're
Okay.
also missing. You got to fix Andy, and then you can
Andy,
also put. You can put Andrew back in if you want.
Oh yeah, yeah, of course. What Andrew? Oh,
And the
quotes.
quote at the beginning of Andy and Andrew.
Yeah, I'm still surprised that vector constructor initialization. Maybe I have to include algorithm. Well, I should have tried this out before class so that we don't waste time doing it. But it's good. It's good that oh, it doesn't have any. Oh, I think I know. Shuffle is not a vector method. It is basically a standard method that takes the vector as an argument. Okay, I think that's what it is. All right, let's see if this works. All right, let's go to Google and find out what is the deal with vector shuffle. Okay, so
Here, maybe you could just try passing it at the end.
Hey, Professor Anand, I sent a
oh, it's called random
line of
shuffle.
code.
Thank you, thank you. It's actually called random shuffle, not shuffle. Okay.
Yeah, and you put the beginning and the end.
I'm sorry. Oh, does it also need the beginning and the end? It can't.
Yeah, I think it's students.begin, comma students.end.
I see.
This is just Stack Overflow, so
I see. I'm going to try it without. Just now, we'll give it a shot, right? Because these delimiters, I think the default should be begin and end, and then it will also take iterators. If you don't give it, maybe. Yeah. Okay. All right. You're right. Okay. Is it students.begin and right here like this?
Yeah.
Okay. So that worked. Okay. So if I run this program.
You need make.
I made it. Select students is up to date. Is it not there? It said, okay. I don't know why. Let's fix that up. On a space cleaner. Okay. All right. So this is the order. And in fact, what we should do, I run it again. Let me see if we get the same order, or is it does it do a seed? Oh, it's not seeding. Let me see. I think I'm. Okay, all right, good. Okay, so this is the order. Andrew wanted to go last, and now he's first. Okay, so the order is Andrew goes first, Giorgio, Andy, we'll refer to this, okay? And Ming, you go last. That's too bad, man. Maybe you get a chance today, maybe you don't, okay? But we'll start with Andrew. Hey, Andrew. Oh, I need to stop sharing my screen, right?
Need to make it so that we can share screen.
Yeah, you can't until I stop sharing my screen. So now, can you try and grab the screen? I can't see your screen yet, but
Give me 1 second.
yeah, sure. Hey, is everybody there? Yeah, we got more students today than last class.
Also, Anand, I sent you two. I assume I should present the shorter one, right?
Yeah, do the shorter one. If you have time, you can also do the bigger one later.
Okay.
And we got more students today than last class, which means that there's a bunch of students today that, you know, are missing some information. I want to make sure that those who weren't here last class, did you get a chance to look at the videos that we posted, the Zoom recordings? Right, you know, and by the way, sorry about last class. I couldn't post the entire recording because, you know, like I said before, I usually do say, you know, I give you incorrect facts during class, but so that you can, so you don't trust me 100%. You should never trust me 100%, anyone 100%, right? You only trust your own good judgment. And you can use these as practice, like machine learning. You say positive example and negative example that trains the system to make fine-tuned distinctions. But last class, I think I said a bit too many of those, and it could end up confusing some, you know, new students. So I don't want to make that public. And so I cut out the bits with Andrew's demo, and also Anthony's demo at the end is there, Andy, and some other people, right? So maybe Stephen. So make sure you read that and see that and get up to speed with the programming. Okay, so once we get faster, you know, moving faster, you'll find all of this comes really handy. All right, thank you, Andy. You're up and ready to go now?
Andrew, yes.
Andrew, yes, thank you. Yeah, go ahead. Explain your code, what it does, and then take it away from there.
Everyone can see my screen?
Yes, we can see your screen.
Cool. All right. So pretty much made a quick code to convert our name into a base 27 representation. Kind of going along with the data representation theme that I've been going on the subreddit with. I knew I needed, at some point I needed a reverse function and an exponent function, the PAL function. As I filtered through Google to try to figure out what the best way to go about it, this library, bit/stdc++.h, seemed to have both those functions. I'm a little hesitant about using this because I'm not sure if that particular library is common, and one thing that we want with our programs is for it to have versatility so that anyone that accesses your code or program can utilize it. So that's something I might look into moving forward.
Why are we using this header file, by the way?
So just to be able to use a reverse function and a power function, exponent function. I know that I can get a power function if I just include math.
Yes.
But math does, and so previously I had IOStream, bits, and math. However, going through some troubleshooting, I figured out that the power function is also included in bits.
Got it, yeah.
The math library out. However, if I only had the math library and I did not have the bits library, I could not do the reverse that I was desiring.
Okay.
There are multiple ways to go about reversing a function, and I'm sure I could improve this. But for now, I just went with this library to cover those purposes. Line 3, we have the using namespace standard, and then line 4, we jump into int main. In terms of this first curly brace, kind of stylistically, some people have it here, some people have it here. At the moment, I have it here. Moving into our first piece, I define my name variable, string name. Then I ask the user to enter their name using getLine, and then this line 12, I'm kind of jumping to the end already. This is what I want my program to print back to the user. I want it to print out the name that they just entered, and then the prompt. So name in base 27 representation is space, and then I will calculate, and then at the end here, I will print the name value. The reason I put this here is because I will be doing, some manipulations on name. So I wanted to print the exact name that they just typed in. Any questions so far? Or does anyone not keep up so far? Cool, continuing on. The next part, I define my secondary variables. At first I had these variables all in one section here, defining all my variables. But because I have not gotten a name from the user, I cannot use this function, or I cannot, I cannot determine this integer array using the name length of the name because I was not given a name yet. So I need to wait for the user to give me a name. So if, for instance, the user gives Andrew 6 characters, then this will give me a an integer array that has 6 integers in it. I also have another integer called name value, and I set that equal to 0. Starting at line 19, I convert the name to uppercase, and then I reverse it. The reason I convert it to uppercase is because when the user enters it, I did not specifically say it needs to be in a specific case. So maybe they enter all uppercase, maybe they enter all lowercase, maybe they enter capitalizing the first letter. Either way, it'll put everything in all uppercase, and then it will iterate. So for integer I starting at 0, as long as I is less than the length of the name, and it will add 1 each time. This will go through and uppercase the name, and after I finish uppercasing the entire name, it will then reverse it using this reverse function. So again, this is the area where I feel like I can improve this program to make it utilize a reverse process that does not depend on this library.
Hey, Andy, instead of reversing it, can you not iterate in the for loop from the end to the beginning?
So I tried that. I tried that here. The reason I want to iterate.
No, I mean up here. I mean here, where you say int I equals 0. Instead of int I equals 0, suppose
yeah,
you
I can do int I equals name length
yeah.
length minus 1.
Yeah,
and
yeah.
I can, yep, and then I can iterate I minus minus.
Yeah, exactly.
So I tried that here. This is where I when I calculate the name value, this is where I need the reversed name.
I see.
The reason I need that, and I can probably find a way around it with the math, is because of the power. Because I'm not only iterating through the letters of the name, I need that power of 27 to match. And so I need W. So let's just use Andrew as an example. W is the character that is in the ones place. I need that W to iterate on I equals 0. Yes, I can probably figure out the math to reverse the math for the power function so that it does the reverse, and I'll give that a try later.
Great.
Continuing on, so I uppercased it, I reversed it, and then I'm converting the letters into a 27 base value. So again, I'm iterating through the same process. I take the each letter in the reversed name. So at this point, we're dealing with Werdna, W-E-R-D-N-A. So each letter will then be given a value based on the ASCII system. From there, I can then, now that I have so previously I had an array of letters, A, N, D, R, E, W. I then reversed that array of letters into W, E, R, D, N, A. And now I'm giving that array of letters, instead of array of letters, I now have an array of numbers, or an array of integers more specifically. I take that array of integers, I iterate one last time, and I take that letter value, I minus 64 because, for instance, capital A is a value of 65. Based on our parameters of a 27 base system, we want A to equal 1. So I take the letter value minus 64, then I multiply that value by 27 to the I power. So again, the first I will deal with W because we have reversed the order. So W minus 60, I think W is 80 something, minus 64 times 27 to the 0 power because we are still dealing with the ones place. I will increase along the name length. Whatever value I get here, I add it to what value is already in name value, and then I store it in name value again. So up at line 16, you can see I initiated name value to 0. So the first iteration will be 0 plus the value of w minus 64 to the power of 27 to the 0. The second iteration will take whatever value I stored in name value plus the value of e minus 64 times 27 to the first power, and so forth until I complete the iteration. At that point, name value has the summed value of all the places, and then I can just print it. I know I spoke relatively fast there. Any questions?
I have a couple. Oh.
So I just wanted to point out real quick that there is a copy of Reverse in Algorithm.
I'm sorry.
Say it a little louder.
There's a copy of the reverse function in Algorithm.
Okay. There's a way I could reverse it if I use the algorithm library.
There's yes, in the algorithm library there is a reverse.
And it's the exact same syntax as you've got here. So at the top where you have bits slash.
Yep.
10,
So I could actually
let's give it that and put in math. You still need math because you're using.
I still need math, and I include algorithm. How do you spell it?
I don't think you need it. Remove. I think it may.
If I don't have it, reverse gets an error.
Okay. All right. So you include algorithm then. Now, even the POW, it'll work. This will work, right? But POW is a double number of returning function, and then for long names it could cause some weird.
It could, yeah. You would need to have POW, you would have to have the base 27 over and over and over again.
Yeah.
But just for part of it is readability. You want
no, this is great. This is great. This is perfect as a first cut. I think not even a first cut, right? Several steps along.
Let's see. This is for
POW.
the POW function.
That's it. I don't.
And this is for the reverse function.
Yeah.
All right. Cool. That cleans up that unnecessary library that's a little too specific for our needs. Why is math underlined?
C math, make that C math. Okay.
There we go.
Now, let's run it. And then, this is obviously every program, no matter how far along we are, there's always scope for improvement. We'll come back and you'll keep tweaking this forever for a long time. So let's get it, run it and do it. And then.
Anyone want to enter a name? Or should I be boring and enter mine?
Try Daniel. He's the first one on my list here. Wow. Okay, Daniel, is that the number you got in your when you did your conversion for posting in Reddit?
Unfortunately, I think it was off.
Wait, Giorgio definitely did his conversion and posted it on Reddit.
I did not just change my script.
I did it with GIO, not with my original spelling.
Yeah, that's right.
So Giorgio with the I.
Yes.
Yeah.
Whoa,
there's a bug. Okay.
Right.
By looking at the bug, you know that it's actually the smallest possible number. So what happened here is probably that
overflow. Is it an overflow issue?
Yeah, I think it's an overflow. What is name value? What is the type, data type of name value?
Data type of name value.
Oh, it's int. That's why.
Int.
Yeah.
So I need to change that to double.
Make that long or something like that. Long. So here's the deal, okay? In case, and I'm glad we covered all the data representation issues before we got to programming, okay? And it's very important. Now, in C++, you know that you can represent numbers using bytes, right? And in 1 byte, you can get up to 255 if it's unsigned, no sign, and 127 if it is signed. We saw that already. Everybody's, yeah? Okay, now, but what if you want to store a bigger number than 255? Then, when the C language came on and said, people are going to require need bigger numbers when they use computers. Well, they're as big as 65,000. Okay, so back in the day, said we want to be able to represent big numbers like 65,000, not just puny 255s. Okay, So how many bits do you need to represent 65,000? 64K is 16 bits, okay? 2 bytes. 2 bytes together, 2 to the 16, that's 256 times 256. That is 65,000 approximately, right? So with 2 bytes, you can represent all the way from 0 to 64K or negative 32K to positive 32K, right? That range you can represent in 2 bytes. However, with these conversions, you're going to overflow even beyond 2 bytes, right? 64K, many of these numbers are bigger than 64K. So what do? So C++ said, or C, right? So not only do we have these 2-byte integers, we'll also give you the option of using even bigger numbers, right? So that's a long integer. They called it a long integer, and a long integer uses 4 bytes. 4 bytes to represent the value, not 2 bytes. With 4 bytes, how many bits do you have? 32 bits. And what is 2 to the 32? That is 4 billion, right? 2 to the 32 is 4 billion. Because 64, 64K squared. Yeah, 64 squared. Yeah, it's 4 billion because 6 squared is 36. Yeah. Okay. So 64K is 4 billion, right? And so if you do signed long, then you go half of 4 billion is negative and the other half is non-negative, right? So you go from negative 2 billion. So divide that by 2, you'll see that number you got, right? Whatever number you got, go back to that screen, divide by 2, you'll see that it's the number you got. Yeah? Right, because now the maximum number of patterns you can get is 4 billion, but half of those patterns are negative and the other half is positive. So what you got was basically an overflow. So turn that into long, and I think.
So Giorgio, does that match the name that the data representation number that you had?
Yes, this is right.
Awesome.
Awesome.
I suspect
But
this program would still create an overflow error on some people's names that are
some
longer.
names.
I also do have another question. So this number, I thought your program created something that could actually represent it in base 27, like the letters, like.
No, he was going.
Well, no, the letter representation is Giorgio.
Yeah, but like the number the number 284 and all, yeah, the big number. I thought you were going for the the base 27 representation of this number.
If we converted this back to our base 27 parameters, it would just print out Giorgio again.
Yeah.
Maybe someone else can do that. And you do the same thing as we did for binary last class, right? Divide by 27, take the remainder. Divide by 27 and take the remainder. And I think we did that for binary last class, yes?
Last week.
Take the remainder.
Last week, yeah.
Yeah, was it last week? I thought it was on Tuesday.
I thought we finished data representation last week.
No, we wrote a program to convert from binary to decimal or decimal to binary.
He knows.
Yeah, correct. Yeah.
Was that Tuesday? Okay.
Yeah, it was Tuesday, right? It feels like last week because we've done a lot of stuff since then. It feels like that to me all the time. Now I have to consciously correct myself and say, hey, no, it wasn't. It was just like yesterday. All right. So that's, I'm sure Andrew could do that, but why doesn't someone else take that on as a challenge, right? Given a number, you got to convert that back into base 27. And print out the name. I think Giorgio was confused because at the top of your program in your comments, you said something about in base 27 representation. Yeah.
Yeah, that's exactly what I was referring to.
I guess my
actually it is right. What he's got is right. That's what it should say. The name isn't in base 27. It will say Giorgio. In decimal, it will say this 28.
I should say Giorgio is the base 27 representation.
Yeah.
Of the decimal number. Yeah, that's exactly.
Yeah.
Is the base 27 representation of the decimal.
Oh, I see. You're okay.
Yep.
Exactly. Yeah. No, don't try Giorgio. We've done that. Try Nicholas. Nicholas. It's a long name, and so let's see if is that correct. Well, unfortunately, he's not here. Nicholas, are you here? I don't know. But someone else who was there, someone else in class who tried their name or discovered the number for their name. Someone else.
Try Anthony.
Anthony, did you do that? Yeah. Is that correct?
It is. Yeah, that's what I got.
Yeah, okay, cool. It's very nice. Yeah, thank you very much, Andrew. Now, this code, I would say, share maybe on Replete, the link on Replete.
Share it on the subreddit?
Yeah.
Will do. I'll also go ahead and share. So this is my more verbose version. I'll share this on the Reddit as well if you guys want to explore. All that this one does, it creates a little bit more user friendliness and asks if they actually want to do it. My whole purpose in this part was just to include an if-then statement. I won't go through this to take up time, but I'll post this on the subreddit as well, and you guys can explore.
Yeah, the important thing is anyone who's reading these programs, if you don't understand something that Andrew or Giorgio or Momo have done, you have to ask, okay? You have to ask, hey, why do you do this on line 47 or something like that? And they will explain immediately, or I will explain. But it's important that you ask, okay? Now, and also keep in mind that you don't have to point out places where people's programs can be improved, right? Because obviously every program can be improved. And that's not the intent here with people showcasing their programs. So for other people to come and point out, holes to fill. If there's a blatant error, that's fine. You can say, hey, you need to fix that. But if it's not an error, if it's an efficiency improvement or something, don't worry about those things, right? I think Don Knuth said that at one time. I don't know. Maybe it wasn't Don Knuth. Maybe he attributed that. Maybe he attributed that to Charles Hoare. No, Tony Hoare. Tony Hoare. What's that about? Something about optimization. Yeah, okay. Premature optimization is a root of all evil. Okay, and it's a very nice and powerful statement. Think about it, right? Because you don't understand, or you don't feel the full power of that statement until many years after you've been programming, right? So in the initial stages, you're not even thinking about optimization. You just want to get the damn thing to work, right? Because most people, just getting it to work is a big deal. But as and when you start programming and get faster and faster and do more and more advanced things, you'll see that, well, it can be improved here, speed it up, and so on and so forth. You make these optimizations, and then you'll reach a stage at where you're thinking, I've got this full product in my mind, and I've also hashed out all the steps, the big blocks, I need to go from here to here, here to here, here to here. And then before you break it down into individual statements, you got this big plan. You've charted out the whole course, right? Here, I want to go from here to San Francisco, and this is, right? So you got the direction, damn, what was it? Yeah, optimization, right? And then you think, in your mind already, you're thinking, even before I go down to implementing these things, I'm going to optimize everything to the depth, right? So squeezing out cycles from here, squeezing out cycles from there, and so on and so forth. When people do that, it is a recipe for disaster, right? For me anyway, I have found that a hard way. During my student stage, I found that the hard way, because if you go in and do these micro tweaks early on, you'll find that it's much harder to debug your program. It's like, when you buy something from IKEA and you're putting it together, what do carpenters and all these builders recommend, right? Do you tighten up all the screws immediately, right? No, you assemble everything and the screws are all loose, right? And then when everything is in place, the screws are in place, then you go and tighten the nuts and bolts of the screws, right? Because you tighten it up, go. Some of these holes may be misaligned, and then you got to loosen up things and align them again. So it's a pain. Exactly the same thing you will see playing out no matter what you do, especially in programming. So when you try and optimize things too early, you're screwed at that point, okay? That really means when you're digging a big trench, don't dig in one place really, really deep, right? And get it all together, and then layer by layer, excavate layer by layer. That's the way. So don't jump in and say, hey, that could be faster, that could be better. No, we want the overall logic, right? We want to see that it actually does its job, which it does, splendidly. This particular program is nice. It's laid out nicely. It's indented. It's the variable names are clear. When you read it, you don't need extra comments, right? So the mark of a good program is really, I think, how little comments you can use in order to for someone else to understand your program, right? So I've seen programs, because commenting, especially for beginners, is actually a fun activity, right? Because they just discovered something, and they also want other people to know that they've discovered it, or this is a cool thing out there. They'll comment every damn thing, right? Even things like I equals I plus 1 or I plus plus. You'll have a comment that says incrementing I, okay? So how many letters are incrementing I, right? Like it's 15 letters or something. Whereas I plus plus is 3 letters. I see that and I know instantly what's going on. going on. So that's a sentiment that we got to keep in check. And so just if there's bugs, you can absolutely point out. No need to make major improvements. Who's the next on the list? Oh, that my screen share is gone. Hang on. But I can find out. It's right here.
I think it's
Next on the list is Giorgio.
Yeah.
Yeah, go ahead.
Okay. Okay, can you see my screen?
Yeah, I can see a screen.
Okay. So I just created a simple integer calculator. I didn't want to type too much complex code for the first time so that everyone could understand. And I didn't do that much of research. I just did what I know so that I could know where are my weak points and where should I start studying, and just know where I lack information on coding.
Sure. That's great.
So as you can see, the first line is just a simple IOStream library. Second line is the standard, using the same standard. So I start my code with the main function, and the first data type that I put was the double data type, which is basically like an integer data type, but yeah, but like for the bigger numbers. So I put three variables: number, numerator, denominator, and result. And I then put a character data type, which stores like a string, ASCII type letters, and I named it op. And then what I did was I did a do while loop. So the first thing that I want to print it out was a simple calculator, was just the program. Then it tells you to enter an integer. Then there's a user input. You type the first integer. Then it tells you to choose an operator, either plus, minus, multiplication, or division. And then it tells you to put in the operator. Then you put in the second integer. And here is the if statement. So if operator, if the user input of the operator is plus, then what the program does is the result is numerator plus denominator. And if the operator, the user input of the operator is minus, it does the minus, and if it's multiplication, it does your multiplication, and same goes for the division. So these are the if statements, and finally it prints out the result is, and the function result, it prints out the result depending on which operator the user put, and the program finishes there. And I put this while operator does not equal to E. I just put in a random letter so that the program continues to run every time the input of the operator is either plus, minus, multiplication, or division.
Right.
So
let's run it.
Yeah.
Very nice. Yeah. Okay.
Okay, so let's say I enter an integer like 10. Enter. It tells me to choose an operator. Let's say I'm going to do a multiplication. It tells me to enter a second integer. Let's say 5. The result is 50. And so the return O basically just returns the program to rerun it from the beginning.
Enter E. Enter E.
So if I enter E for operator, I think the
Oh, for operator. Yeah.
yeah. So let's say 6 plus operator E.
Oh, and then what happened? Did it exit? It doesn't say that.
It exited, but the result is from the
Yeah,
previous
result
50.
is the previous result, but the program didn't rerun it back.
I see. Okay.
Yeah.
I mean, basically it works. It just needs some cosmetic tuning, right? Yeah. So that's very nice. Who's this? Giorgio, right? Giorgio,
Yes.
nice. So one minor thing I would like to suggest is a stylistic issue, is that you're calling your variables num and din, right? Num and den. Numerator and denominator is what I think you had in mind.
Yes.
Okay, all right. I would suggest that, the compiler doesn't care, but call them A and B or X1 and X2, really.
Okay.
You don't have to change them now, right? Because you have in multiple places and it doesn't let you refactor code.
Yeah, but
Does let you refactor?
Excuse me?
Does replete let you refactor code? I mean, right click on one of those guys, right click on, select den and right click there.
Yeah.
Say refactor. Oh, rename. Yeah, okay. So it actually does like that. So select rename symbol. Make that X2.
Wow.
X2.
Okay.
Yeah, enter.
And then
Did it change all the dens?
Yes.
It changed all the dens?
Yeah.
Yep.
Oh, cool. Okay.
Yeah, but what I read it was, I think it was on one of the modules, the mycolosis modules, or I don't know, I don't remember, or either it was on the internet, was that it's not good to put like single letter things, single letter.
Yeah. But one of the
you could still do you could do VAR, variable 1, variable 2. I think the reason that Anand is steering you away from num and den is because naturally someone familiar with math would think numerator and denominator, and that would be more specific to division and not apply to addition, subtraction, multiplication.
Got it.
Awesome. And I noticed one other really quick thing that Okay. Is it okay if we make a minor change as an experiment and an instructional piece here?
Sure.
Is that okay? All right. Yeah. Now change all your if statements, right, to else if statements. Not the first one.
Okay.
This is the last three. Else space if. And then add an else statement at the very end after the last one. Else.
And
at the last one, yeah, just an else, not an else if, just an else. Okay, next line. And then you say, see out. I don't understand this operator. Please try again, right? I don't understand this operator. Please try again. And I'm going to introduce one more thing here, which is really cool and it's powerful. Okay, I'll finish this first. And then endl after that. Okay, that's fine. That'll do. All right, semicolon. Now, we're going to do something here, which is a new feature. So after that else, right, we want to block, not just one line. So put in a brace after the else.
After the else?
Yeah, after the else, put in a brace. Open a brace, curly brace.
Okay.
Yeah, and then after your cout statement, hit enter. Oh, get rid of that closing brace there.
Yeah.
Right, and then after the cout, go to the end and hit enter.
Okay.
And type continue. Okay, and then semicolon. And in the next line, close that block.
Yeah.
Okay, now also I want to do one other small cosmetic shift here, right? Now, you notice that you exit the program if the user typed E or Q, E, right? E, but you exit it after you've accepted the input from on those other two, for those other two variables, right? For the other two operands. Now,
Yeah.
suppose I want to exit the program, I still need to give you the two operands. Yeah?
Oh yeah, yeah.
So that's something you can work on later. Just as a user experience point of view. If the user wants to quit, you should do that immediately before you
Yeah,
get any more input
before
from them.
the
So
operand.
yeah, get the operator first, and then you can do that now if you want. If we have time, we can do that. But essentially, here's what you would do, right? So you would get the operator first and do the comparison right there at the top. If it is equal to Q or E, you just break out of the loop. The statement for doing that is the same as continue, except instead of continue, you'd say break, right? Break means it'll leave the loop. So
Okay,
yeah. So we'll get back to this program. Keep the program after everybody's done their demos. We can always come back to this and
so from what I understand, we could do like a break statement and then put in the variable like one of the operands like x1, and then if x1 doesn't equal to an integer,
no, not
then
x1. No. The first thing you accept from the user should basically be the operator, right?
okay, got it.
The first question, yeah, you say, what do you want to do, right? And pick one, right? And plus, minus, star, and slash.
So the first thing is to choose the user to choose the operator, and then if the operator is not one of these four, the program breaks. Got it.
And in fact, you should, I think you could even be more explicit to the user in terms of the prompt. When you say choose operator, you can have those four symbols, plus also, Q to quit or E to quit or something like that right there in the prompt. So user knows what to type in order to get out of your program. But right now they don't know, right? They got to type, keep hitting A, B, C, D, E. Oh, E worked, okay? So we want to make sure the user knows what they need to do.
Got it.
Okay. Good job. I like this program. It's very nice. It actually does something. Yeah. Very nice. Thank you, Giorgio. All right. Who's next on the line in sequence? Andy. Oh my gosh, Andy has to go at 9 o'clock.
Yeah, Andy put in the chat box that he left
Bummer. He should have told me because we could have had him up front, at the very beginning. Okay, Sumaid, you were going to go next, right?
Yes.
Okay, all right. Okay. Is your code up?
Yes, let me share. Oh, I'm not able to share for some reason.
Oh, because Giorgio still has it?
No, it looks like.
No, I stopped sharing my screen. I don't know.
Yeah, you stopped sharing, right?
All right, you want to figure that out while we do?
Yeah, let me figure this out, yeah.
Okay, Steven, you're up.
Okay, hold on. This is like a really simple code, not as complex as the other ones, but just like a validation of your age, I guess. It basically says here, please enter your age, and then integer A is defined to be what your input is in CN, and then if you are older, if you put that you're older than 120, if you're less than 120 or greater than 0, then it's basically saying you are this many years old. Is assuming you're telling the truth, and then else, no, you are not this years old. It's just very simple.
So who's the oldest person on Earth right now? Someone in Japan, I think.
I'm not sure.
No, it won't work for them, right?
Yeah,
okay, all right. Let's just say that they're not going to run this program.
I doubt they're older than 120.
All right. Cool. Run it.
For example, if I put -10, say, no, you are not -10.
Yeah. Try 120.
Okay, hold on.
Great.
I
yeah.
think
Anything other than that, it should work, right?
I think he should put an extra, like an equal sign, if he wants to run that 120.
Yeah, maybe I should put an equal sign.
Yeah.
And
Yeah,
also people also could be 0. So.
yeah.
No, I think the second one should be greater than 0 because, I think there might be a really, really precocious child, as soon as it's born, say, hey, where's my laptop? All right, born with an iPhone in their hand, punching their keys, programming while I was born. Okay.
No, you're not 0 years old.
All right.
Okay. That's all. If you have any questions or any suggestions, you could.
Very nice. Hey, when you save this code, indent the inside the if statements, inside the if block, indent it in, and not yeah. Okay. Oh, there's one more space up there. Yeah. So you can do that. And the other thing I try to do is also separate out vertically inside blank lines. Yeah, where you can look at your program like you would if it was an English essay, right? So different conceptually, coherent chunks. Yeah. Nice. Very nice. Yeah. No. Keep all the declarations together. Oh, you have a yeah, that see out statement above the declaration needs to go below, right? So it's nicer to organize things like that, right? So see out is actually doing something. You don't start doing something until you finish all the declarations. Well, not strictly speaking, that's not true. But in this case, see out should go after the declarations, after int A. And then after int A, now you can have a blank line because the declarations are done with that space.
Sure.
That is much better. Now it's grouped nicely. Yeah, agree?
Yeah.
Okay. I also usually have a space after the else, but that's okay. Yeah.
Okay.
Yeah. Very nice. All right. Thank you very much, Stephen. That was also, and return was also not indented. But those are cosmetic details you can look at.
Got it.
All right. Who is after Stephen?
I can go. I'm able to share my screen, I think, now.
Who is this? Oh yes, Sumedh.
Yeah.
Yeah. Go ahead. Go ahead.
Looks like I had to give my.
Okay. All right. Go ahead.
Okay. All right. Yeah. So real quick, I kind of just whipped this up real quick here, but yeah, basically there's a program to essentially check if you're wearing a mask, and if you are, you'll get let in, presumably like enter some kind of store. If not, then it just kind of tells you to go find a mask and just tries again, a few times until you exceed the retry counter.
This is assuming that the the person in the store is not looking.
That's true. Yeah. So yeah, this is supposed to be the computer that checks for it, I guess. Yeah.
Well, even as a computer, we're assuming there's no camera and visual processing, right? It's just a blind thing that asks you and takes.
Right. Yeah, asks you and you have to enter. Yes. Okay, exactly.
And you only have 5 chances, right? If you come back to the store 5 times and not wearing a mask, you're finished.
Yeah. So obviously this could be expanded and be made much more intelligent. But
of course.
At a first level, we have string user input, and we start our retry counter at 0. We check in our while loop, our condition to get out of this loop is if we exceed the retry counter. So yeah, first question is, are you wearing a mask? These are your 2 options. You can say Y or yes. Anything other than that will not be allowed, essentially. So we check if the input is either Y or yes. And if it is, we say, thank you, you can enter, and then we break out of the loop. Otherwise, we say, you need to go find a mask, and we increment that retry counter and retry 5 times. Cool. So yeah, very basic, but
they can type yes also. Yeah, okay. So you're accepting both forms of input. Yeah, cool.
Yeah, anything else other than Y or yes will be so yeah.
It won't accept a lowercase y or lowercase yes, would it?
I don't think so. No. Yeah, I was thinking maybe one way would be like we could have like maybe an array of acceptable inputs, and we could put like lowercase y, uppercase y, yes, and then check if the user input contains those, like anything in that array. That might be one potential way of
So
optimizing.
here's an idiomatic way that people usually handle this exact situation that you're describing.
Yeah.
When user input can match any of a number of different options, what people tend to do, the easiest way to do is to what is called normalization of the user input, meaning that you don't care what it is, but you're always going to turn it into one form that is predictable. So what you would do is, if you're only interested in the first letter, you take the first letter, extract the first letter, and convert it to uppercase. Then you don't have to compare it to lower and upper. You know only to compare it with uppercase, right?
Got it.
So
Yeah.
you can do it that way. So you normalize this. Yeah, believe it or not, when you get to data processing and machine learning and things like that, data normalization or canonicalization, as some people call it, it will take you a huge amount of time. Right? So in natural language processing, I think it's safe to say that more than 25% of your effort, sometimes even more than 50% of your effort, is really to do with data normalization, right? And when it comes to training, sophisticated machine learning systems or deep nets, people have this mistaken notion that they can just get gobs and gobs of data and throw it at the net, and then it'll learn some mysterious mystical pattern inside of it. Well, that's not true at all, right? If that is the case, then you won't need to learn computer science to do machine learning, right? The reason well-trained computer scientists are good at machine learning, not just people who are just applying the concepts, applying the technology that's out there, is because by knowing computer science, you would be able to normalize the data in such a way that the system will not spend a huge amount of time and compute cycles and machine resources just trying to filter out the noise. Because you take a lot of data, it's bound to have a lot of noise in it. And the way you train a system is not by throwing the whole thing at it. Eventually it'll learn with lots and lots of data and lots of noise, but it's not going to do it in the next 10 years for you to make money, right? So what people do is take that, lots of data, and then use their own intuition to say, well, this data is not going to be learned from effectively, so I'm going to filter out lots and lots of stuff. I'm going to convert a whole bunch of these into some normal representations, make them all floating point numbers, make them all span 0 to 15 or some range and things like that. And it's called normalization of the data. Only when the data is normalized, you can find patterns in it. Now, this normalization of the data is exactly the same as you would do in physics or chemistry when you control an experiment, right? Think about it. It's exactly the same. What do? When you run an experiment and the situation is not controlled, there's a whole lot of things that could be happening, right? So the temperature could be different, the lighting could be different. And so when something happens, you don't know why it happens, because it could be due to A or B or C, you don't know, right? So if you want to identify exactly why it is happening, you need to make sure that, there's all these other things, but my intuition tells me that the temperature, or no, let's not think about the temperature. Yeah, my intuition tells me the fact that I had, I just ate a cookie this morning will not have an effect on the rate of growth of a plant in your garden. It's a safe assumption to make, right? So maybe there's a very, very slim chance, but there's a safe assumption. But when you collect data, all of it is in there, right? So you have a plant, sprouted 10 new leaves today. What happened yesterday? Oh, Ananda ate a cookie, right? That's also in the data. So for the system would say, well, eating a cookie resulted in 5 new leaves. Well, not the only reason, but lots and lots of reasons. But then that just means that it needs even more data to filter this out and say, well, I've got other data in which the leaf, the plant grew, but he didn't eat a cookie. So now I know that this can be taken out. And so that's how machine learning happens. Machine learning is essentially the discovery of patterns by an automaton. And in order to make it easy for the system to discover the pattern, you need to make sure the pattern is visible and not shrouded in lots and lots of noise. So that is where a great deal of ingenuity of computer scientists and machine learning, the AI people go, is not in really feeding it and looking at the output, really in trying to determine what needs to be given to the system in order for it to learn the pattern, right? Like good parents, right? Good parents will say, the child needs to learn something, but, I'm not going to throw everything at it. This is not going to be successful, but instead I'll just, using my own experience, I'm going to filter out everything that's not going to be helpful and only give you the stuff that's useful. And that is where we want to go eventually, right, with computer science. And I don't know why we started talking about that, but essentially, yeah, that's what we need to do. And thank you. This is pretty cool. Why did we start talking about that? Yeah, normalization of the data.
Normalization, yeah.
So, yeah, normalization is very important. It's a powerful technique, right? Because I know, not even talking about machine learning, right? I've seen code even at the 2B level, not 2C, right? 2B level, in which students spend a lot of, like sometimes 30 to 40 lines of code, just trying to compare what the user, not even the user, right? So compare some string to like 50 or 60 different options. Why, right? Just convert what the user entered into one standard notation, representation, and then you have to compare it only with one or two. So, and that's a trick, right? Remember this and, tuck it away in your inventory of things that you can use, because then that'll speed up things you can you implement much faster.
Cool.
Thank you. That's great. Who's next on the list? Thank you, Stephen. That was Stephen, wasn't it?
It's Sumedh.
Oh, Sumedh. Thank you, Sumedh. That was a very nice program. And you're also going to share it, right? All of you guys, please do share it, because these are useful programs that will be, very, very handy for people that are revising. They're not revising, they're reviewing their code before the exam, before the midterm. All of this is going to be like super duper useful. So who knows, maybe 5 quarters from now, and maybe when you start working, right? You finish your graduation, you're working, and all of a sudden you get a notification from Reddit saying some student in 2015, no, not 2015. What year is 2020 now? Hey, some student in 2025 voted up Sumedh's answer code because it helped them. Right. So cool. All right. Thank you very much. Who else? And all of you guys who are not demoing today, take a look. Okay, follow along. I hope all of you guys who are not demoing are basically following along and not just switch on your Zoom and took off. Okay, because I don't know, right? I just see your name in the chat window. I don't know if you're active or not. Maybe you just started the session and took off.
Yes, we're here.
Thank you. All right, so you have to be participating in order for me to know that you're here. And all right, who else? Who's after? This is Daniel?
Yes.
Daniel, go for it. And then we got 4 people after you, Daniel, and we have about 20 minutes left. So yeah, 5 minutes each. That's fantastic. Great.
Okay, so I'll just share the screen and let me just full screen this. So first off, I have this program, which it's a very traditional FizzBuzz game, and although I'm using a few things. So first off, we have this thing, which it's basically just telling the compiler to put this number wherever I have count, to put 100 wherever I have count, and then we just have main, which means for loop. Where the interesting thing about this for loop is I'm just incrementing I before I compare it to count, because honestly I didn't want to have just int I equals 1, so I just am incrementing I at the beginning.
Hey, Andrew, why, Daniel, why do you say you're incrementing I before you compare it to count?
Well, because honestly, I find it just easier to comprehend when it's just automatically int I equals 0.
No, but I'm saying that it does not do that. It is the way you have it.
Plus I is incrementing I first.
Yes, yeah. No. That statement plus I over there is no different from I plus plus. It is exactly the same. In that context, the increment operator does not make any difference, right? Because it's a statement on its own. It's because the comparison has already been done when it gets to that place.
Okay.
Yeah. So don't worry. You want to start at 1? Is that what you're saying? You want to start at 1?
So I guess I'll just real quick format it to int I is 1.
And it doesn't matter. You can have plus I or I plus plus. It doesn't make a difference.
Okay.
Yeah. So yeah, if you start at 1, that's fine.
First off, another thing is that I don't using namespace STD, because using namespace STD defeats the purpose of why STD exists in the first place. So
it's fine.
So I just am creating this string out, and then I'm using the ternary operator to, if I divided by 3 is 0, then I know, and as per the rules of the game, add fizz to it.
Uh-huh.
And then I do the same for 5, and buzz, And then if it's not there, you just print the number or out, and that's just another ternary operator. And I just put an end line and return 0.
Very nice. That's really cool. This
I
has a lot of features. Yeah, a lot of features built in a very small space. So yeah, this program absolutely needs to be shared and people discuss it. One thing I would suggest really is try not to use preprocessor directives from C, like hash define and things like that.
Yeah,
there are multiple reasons for that. I won't go into that now, but it's better to use a declaration. And if it's a number like this, just a const int, whatever that is, equal to 100. Right? So I think that would...
Also, if I run it, you can see that.
Why is it printing them all in separate lines?
Because I think I am including an end line.
After every... No, but I see a fizzbuzz, one word. Up there.
Fizzbuzz, it's because I print every number on the same line, but I'm adding to a string. So if I when I'm doing the calculation, I'm just running this for every account and I'm outputting it. But since
I see, got it.
I'm printing fizzbuzz on 2 lines, printing fizzbuzz on because the rule is also if it's both, then it's 50. Like,
I see. I got it. I've never played this game before. This is a really nice game. So if I say fizzbuzz, it means that it's divisible by 15.
Yes, or rather divisible by 5 and 3, which means it's divisible by 15.
Yeah, nice.
Ternary operator by just doing it with string addition.
Yeah, run it again and type in a. Oh, it's going to do 100 of those.
Yeah, it does 100.
Yeah. Okay. All right. That's fine. But you can also change the program at some point to accept user input and say, well, your number, this is the fizzbuzz of that number. Yeah. So you don't have to do it now, but that will be more interesting for many people than to see some random number fizzbuzzed.
Mm-hmm.
Very nice.
100 is, which is why.
Yeah. Change that into const int count equals.
Actually, I'm going to do const uint 8t because smallest number possible is more memory efficient.
Yeah. So what Daniel has just done is said that count needs to be an integer, is stored in 8 bits, and it is unsigned, right? So that's what uint 8_t means. But it's a real mass. You can just use uchar, right, if you want. Uchar. Uchar is also the same thing.
I'm just used to Rust, so I usually just explicitly define it because I'm used to using that type of notation.
Don't worry. I just made that comment in case other people who are looking at it suddenly thought, oh my gosh, this is C++ has got stuff I can't even pronounce, right? And they'll get turned away. Don't do that. Not you. Don't get turned away because it's, there's simpler things, simpler ways of doing the same thing too. Great. Thank you so much, Daniel. That was really nice. Right. And make sure you share this code also. Right. What I would prefer, if you don't mind, is let me start a thread on Reddit, on our sub, or someone, right, Andrew, or one of you guys start a thread and share all the code in the same thread, right? So maybe call the thread class demos from, what is today's date? Class demos from October 8 lecture or something like that. So this will help not to clutter up the feed so that when people go into the subreddit to look for questing related stuff, it's not like drowned out in these class programs. So make one thread and we'll post all of them as, comments on the same thread. Is that okay?
Yeah, that should work. I'll probably put mine in a paste service so I get syntax highlighting and then put a link to that.
Yeah, okay. Just make sure, because if you put it in a paid service and then all of a sudden you stop paying and then people who click on it just get to a 404, then your post will get deleted. Yeah. So make sure you got those covered, and you can just share the code using Reddit formatting. Reddit subreddit format. This is only 15 lines, right? So in your subreddit input, you just format it like code and paste the code there. Then it's there. You don't have to worry about cpp.sh is down and my post got deleted because it's a dead link. So you'll be safe.
Okay.
All right. Thank you very much, Daniel. Who's next? Momo.
Yep. I'm gonna share my screen. Let's see. All right, cool. Can you guys see that?
Yeah, I see it.
All right, so I just I made a pretty simple just BMI calculator. It'll take inputs from a user.
This is Visual Studio?
This is C-Line.
Oh, is it a C-Line? Okay. It looks very much like VS Code.
Yeah, so basically it takes in inputs of your height and weight in a, and basically kind of like, I use getLine. So I think based on last class, my understanding was that if you use getLine, whatever input you get, even if it's like a number, will be a string. So I had to basically convert that string into a number. So I turned that into like a float, because you can be 1.5 meters tall. And so height num, and then I did the same thing as weight. And then basically had some kind of user interface thing going on, saying we're calculating your BMI. And then BMI is basically your weight divided by your height squared. And so I kind of just made another variable called height squared, and used the CMath.
And a height in meters, is it? I see.
It's in meters, yep.
Okay.
Yeah, and then basically it'll categorize you where it'll output what your BMI is. And then it puts you in what kind of range you fall in. I try to make it so that it would, I think I try to make it so if you put like an improper weight or height, it would say that, I'm sorry, we cannot calculate your BMI, but that didn't really quite work for me. I'll just run it though, and maybe I can get some.
Let's take a look.
Oh shoot, okay, this is, okay, there we go. So height in meters, I'm 1.68.
Where's the output? I don't see it. Do you guys see the output?
I haven't put it. I just ran it. Wait, do you see the compiler on the bottom?
I don't see the console.
Oh.
Who sees the console?
Yeah, we can see it.
You can? Can
No,
or can't?
No,
cannot.
There's no console.
Cannot. Huh.
Yeah, Alexis also said can't see it.
Let me just stop real quick.
Oh, in this case, the chat actually came up here in a little bubble, but usually the chat doesn't come at all, and I have to. Hey, Alexis. So it would be better if you just, all of you, right? Not just Alexis. Just hit the space bar and speak it out, right? It's much better, easier for us to hear you and respond than to keep looking, or you locate the chat window in the first place. Okay, so hit the space bar and say yes or no. Is that okay?
Let me just run it on REPL. Okay, wait, sorry guys, my computer is actually freezing up right now.
All right, well, we can come back to this after the next demo. Momo, hang on to this and figure out what the hell is going on.
Yeah.
And then we'll come back to this. The only stylistic comment I would have is that you have a string, height num and weight num, but whereas in the other two variables you just have height and weight, yeah, and they're strings. So just to make it all more symmetric and clean and self-documenting, if it was me, you don't have to do it, I would call the first two variables also height str and weight str, so it's clear. Especially if height and weight are numerical quantities, people are likely to confuse.
Yeah, okay, that makes sense. Yep.
All right, great. Who's next? After Momo, we have Adam.
Yes.
Adam Ming. Yeah, and we have. Oh my gosh, we are at 9:45. So we got 3 people to go. Can we do all 3 in 10 minutes? I'll promise to keep my mouth shut. Okay, go.
So basically, in one of the lectures, Anand was talking about how like the computer reads the information, right? It would not go like in, for example, a book. You open a book, and then if you need to find a certain information, a certain word, you would not go from the first to the very end, because it's not time efficient. You would rather open the book in the middle, and then you will like know, for example, if it's like M, and then you need a certain letter, you would know if you would go to the like lower side or the upper side. I mean, like on the left or right. And therefore, I had this idea like of the random number generator but I was not able to do it by myself because, well, I have no experience in C++ before.
You are a C
Therefore,
programmer, I assume.
excuse me.
I assume you're a C programmer?
Uh, Not really. I used to like C sharp, just a little.
Because you used put S, that's why I said
Yeah.
that.
Oh, okay. So basically, I was like looked up the what would you use like to generate a random number in C++. So use the function crand. So in order to generate a secret number in here, like it's from 1 to 10, I have this code on the line 10. So, well, I'm not able to explain it properly because like I myself don't really understand it.
Don't
I
worry
just
about
like,
that. We'll
yeah.
come back to this because we're going to be using srand and rand later on in our class, and we'll have an opportunity to dive deeper into those things. But what he's doing is essentially generating a random number between 1 and 10, using the statement the cursor is on right now. And forget about srand right now. Srand basically says, give me a different random number each time I start up the program, right? Otherwise, it'll give you the same sequence of numbers, right, to shuffle it. All right, so go ahead. Let's run it and see what happens.
Basically, you have to guess the number from 1 to 10, right? And then if you run it, it's like the prompt. Yeah, it says guess the number from 1 to 10. You would pick a number. Let's say 5.
5. Okay.
Well, here actually I got it from the first try, but
run again.
I just want to try it again. Yeah, it rarely happens. It's 2. The secret number is lower, and then the only lower number is 1. So obviously, yeah, you get it.
Oh, okay. Oh, it can be 0 because you're adding 1 to it. Okay.
Yeah. Yes. Yeah. I added 1. Yeah.
I see. That's nice. That's nice. And it's also interactive and it's fun. The only comment I have is it's better generally not to mix, C output, C stream handling and C++ stream handling, right? Because puts does things differently, and gets also, right, does things differently. Just stick to C and C out, or I think just stick to C and C out. No, don't have to do it now.
Yeah, because I was looking for the tips in the internet, and it said like the program was using like printf and scanf, and I was not really familiar with that.
Yeah.
So I just used the C out and C in, but then I was not able to like.
No, here, where you have on line 15, where you say puts, right? Instead of puts, you just put C out double less than.
Oh, over here?
Yeah. C out double less than. And then puts always ends with a new line, but now you have to give the new line explicitly. Go to the end, get rid of the parentheses. No. Get rid of the parentheses around the secret number is, right? And then put a new line or endl at the end, and you're done with that particular put s, right? Yeah, double less than before the endl. Right, that's all you have to do. Everywhere you have puts, you would do that, but don't do it now, right? But that's
all right. I got it. Yeah.
Okay. Awesome. This is very nice. Thank you. And I'm happy you're sharing this code.
Thank you.
By the way, who was this again? I forgot.
Adam.
Adam. Thank you. All right. Who's next? Sumit. You here?
Yes. Hello. I'm here. All right.
Okay.
Let me share my screen. Can you hear me okay?
Yeah, I can hear you. It's just fainter than the others, but I think I can hear you.
Okay, cool. Someone's still sharing screen, so I need to wait for them.
There you go.
All right. So this is my little program. Basically, it's just asking the user to input 2 numbers, and then it'll just input or output the maximum and minimum of those 2.
Oh, I see.
So basically, we define the 2 numbers, and then ask for the first number, then ask for the second number. And then using these 2 methods up here, we just calculate the maximum and minimum using the ternary operator. Up here, I wrote a little comment.
Yeah. I love that we're coming up with situations where we can use these ternary operators, play around with this. Thank you so much.
Yeah. Because like the first time I saw it, I was really confused, but it's really useful if you understand.
Yeah.
So let's go ahead and just run it real quick. So first number, we can enter like 7, and then next number, we enter like 34. And it'll say the maximum of these 2 numbers is 34, and the minimum is 7. So that's basically it.
Run it again, give 2 identical numbers.
If we enter like 12 and 12.
Yeah, okay, fantastic.
Yeah, that's it.
Yeah, it is correct. The answer is correct. Yes, because you can have 2 maximals and 2 minimals.
I'm assuming this would also work for negative numbers, right?
Yeah, it should. I didn't test negative, but
it should. There's no reason why it shouldn't.
Like negative 12 and negative. Yeah.
Wonderful. This is nice. I like this. It's everybody's done programs and they're not all the same. That's the beauty of it, right? Because I originally, when I started, I thought, when we started today, I thought, oh, it's going to be like 4 or 5 programs doing the same thing. We're all doing very different things, and each one is a different program. Lovely. Who's the last? Thank you very much, Adam. Adam, wasn't it? Was it Adam?
That last one was Sumit.
Oh, Sumit. Thank you, Sumit. Thank you very much. Very nice. Okay, Ming, you're on. You're the last. We got to you.
Okay, so I just share the screen. So can you see it?
I can see it.
Okay, so this code is very similar to Momo's one, and basically what I want to say is that if you place the one order of the condition for the if statement, then you get the wrong output. So let's say if I get a 100 score, and then but I still get a B, C, D, F because I use the wrong order for the condition. So in this case, I think it's important to specify each case.
Right. Because you're using else if, you don't need the first part of each of these conjunctions, right? Because it wouldn't get there if it was less than 91. If it was less than 91, the first if would have got it. Yes?
Yes, it will skip the remaining part of this block.
Yeah, so you can get rid of the score greater than or equal to 91.
Yes.
On line 12. Yeah.
So that's it.
Did you run it? What's it doing?
Yes.
By the way, hang on. I want to find out what it's doing.
So this is to use to determine your grade based on your score.
Great. Okay, yeah. Okay, I was thinking about number conversions, and I thought, what the hell is going on there? Yeah, great. All right, this is from the syllabus. Did you pick up this thing from the syllabus?
Yeah, I picked it up from the syllabus.
All right, but did you understand what I was trying to say? You don't need on line 12. You don't need the score greater than or equal to 91 and the double ampersand. You don't need that. Yes? You only need score less than 97.
Oh, right. Yes.
Yeah? Because if it is less than 91, it would never have got there.
Yeah.
Yeah, so you can get rid of those comparisons.
Okay.
All right. Very nice. And I'm pleased that we actually went through, we got through all of your code today, everybody who volunteered. Now, I want to hear from the people who didn't volunteer today. Are you now feeling more comfortable and braver for coming forward with some of your own code? It doesn't matter if it doesn't work. We'll all get together and fix it. But are you guys now feeling more comfortable? Next class, I'll try and come up with more interesting things that you can, proposals for you to work on. But I would like to give preference, right? Not the ones who've done it already are not prevented from doing so, but I would like to prioritize the ones who haven't had a chance to show their code, okay? So the more you do this, the more you stick in my mind as, when it comes time to participation points and so on, I know, right? So I look at the names, oh, Gaomang or Alexis, yeah, they did these things. So I give more points to you guys, okay? So take your and if you do demo and you're not demonstrating your code because you're, I don't know, you feel that you don't want to, show your code in public on Reddit or something, do it anyway and let me know so that when I get the video, I can edit out your portion, right? And make sure that, Alexis said she doesn't want her code in the shared video. I can go in and excise it, take it out. So let me know. So that's not a reason for you not to demonstrate your code. So do demo your code, let your friends and your classmates look at your, beautiful program, and we'll all enjoy it together. How is that? So did today's class help you guys in assimilating some additional new concepts?
Yes, absolutely.
Yeah.
Great. Now,
Yeah,
it's
definitely.
important that we continue to play with it, right? So it's not enough that the end of this class, but that it's not enough to just forget about these things and move on. You keep playing with this, right? Keep playing, do more code, try more games, implement the game that Ming, no, not Ming, Sumit. So one of you guys, right, did a game. It's really cool. Or the buzz fuzz from Daniel.
I'm sorry to interrupt, but I have to go. I have a math class.
Yeah, that's fine. Thank you so much for your class. You guys are coming back on Tuesday?
Yeah, sure.
All right.
Anyone that has a code, I started a thread on the Reddit. Feel free to reply to it, and I think it would be great if everyone kind of not necessarily explored every code, but yeah, explore a couple of the codes that get posted, and we can further discuss so that we get everyone up to speed or even more in depth.
Yeah, even if you didn't share your code today, right? Even if you didn't share your code today in class, share it on the Reddit thread that Andrew created. And then, was that Andrew? I didn't see.
Yeah.
Yeah, share it on that. Share it there. Okay, so that might be a breaking in for you. If you were too too shy to show it on in the Zoom session, share it in Reddit, and then we'll take it from there. Thank you so much. It was a great class. I enjoyed this class today. All right. So I'll have a great weekend, and I will look forward to seeing you guys again on Tuesday, unless you guys want another class in between, and you let me know. Okay. All right. Thank you. All right. Bye.
Thank you. Bye.
Thank you.
Bye.
Have a good day, everyone.